Okay, so in the last video, we talked about making a solution by massing out a certain amount of a solid. So you had some solid stuff and you weighed it, and then you put that into a flask, and then second step was you added water. That is making a solution by mass. But sometimes you don't have a mass of something that you need. Instead, sometimes you have a liquid solution and you need that has a certain concentration. So we're going to say that this that I'm pointing to right here, here's the pointer, that this solution has a molarity, a concentration of 4.8 molar. And since we just learned about acids, we're going to say that this is an acid. We're going to say it's nitric acid, HNO3. But let's say we need to make a solution. We can't use 4.8 molar in our experiment because it's just too strong, too concentrated. And we need to have a solution that is, let's go with, where's my pencil, 0.73 molar of nitric acid. That's the concentration we need for the experiment. And we don't need 1 liter of it. All we need is a small amount. We only need 100 milliliters. So in that case, we can take this concentrated solution that's a much greater concentration, and we can use it to make a solution that is not as concentrated. So it would be weaker. It would be, I don't have a lighter blue pen, but it's not going to be as strong as the one over here. And we're going to just take some, what we're going to do is take some of this out and use it to create this weaker solution over here. This method is called making a solution by dilution, because you're taking something that is more concentrated and you are diluting it to make something that is less concentrated. So let's talk about how we would do that. So if we want to make, I want a different color, I'm going to use red. If we want to make a solution with this concentration and we want this amount, we know that our molarity has to be 0.73 molar and our volume is 100 milliliters. And we're going to need to know, in order to make this, we need to know how many moles of nitric acid do we have in here, because concentration is in molarity is moles over liters. So we have to find out how many moles we have in here. But when we measure concentration molarity, it's moles over liters. We know that we have 0.73 molar. I'm going to erase that line. And we know that our volume is 100 milliliters, which in liters would be 0.100 liters, and I'll show you how I did that. So if you have 100.0 milliliters and you want to know how many liters it is, there are 1,000 milliliters in 1 liter. You need to know that, and then you can cross multiply and figure out that 100 milliliters is the same thing as 0.100 liters. Actually, I need another 0 here because there were 4 significant figures here. This only has 2 significant figures though, but we'll deal with that later. So we need to know how many moles we have, or we need to have in this flask in order to finish making it. So X moles goes here. When we solve for X is going to be equal to 0.73 molar times 0.1000 liters. So X is equal to 0.073, and let's think about what our units would be. So big M right here could be rewritten as moles over liters. So when we multiplied, where's my pointer, this by this, our liters canceled, and our unit here is moles. So that's how many moles we need to have in our flask. Which means that if we're going to be taking moles out of here to put in here, we're going to have to take out, what I'm coloring in red is going to have to be 0.073 moles. Well, how am I going to do that? How am I going to measure 0.073 moles out of here? I don't have anything that measures moles, but I do have devices that measure volume. I have graduated cylinders and I have pipettes that measure volume. And I have a relationship between volume and moles. It's called molarity. Molarity gives me a relationship between moles and volume. So on this side, if I need to take out 0.073 moles, and I know that my molarity is 4.8 molar, I can use the relationship between these two to calculate how many liters I would have to take out. I'll use this equation to calculate how many liters I would have to take out in order to take out this many moles. So now if I solve for x, I will find, pause, I'll find that, oopsies, x is equal to 0.073 moles divided by 4.8 big M, which is the same as moles over liters, which means that x is, and my moles cancel here, and I have a liter in the denominator here, which is the same as having it in the denominator of the denominator, which is the same as having in the numerator. So now my x is equal to, I just did this on the calculator, 0.015. I'm just going to write down a couple of more significant figures. 2, 1. So I have extra significant figures right now, and these are liters. So I have to take out 0.01521 liters from here. And to be really precise, I would use a pipette, not a graduated cylinder. I would put a pipette in here. Let's do that. And I would measure out, and that's what you're going to do. You're going to use a pipette, and we'll learn how to do that. And you'll measure out 0.01521 liters, which is 15.21 milliliters. And then you will put that in here, and that's not going to fill this whole flask up. It's just going to go to down here. So just a little bit, 15.2. This is a 100 milliliter flask. We're putting in only 15 milliliters. But now we're going to dilute it because we're going to add water. We're going to add water to fill up the rest, and that will dilute it to this concentration. And then we will have 100 milliliters of this concentration. So that is how you create a solution when you have something that is more concentrated and you want to use that to create a lesser amount of something that is less concentrated. The end.